Welcome to lesson 1.6, Use Precision and Measurement. Now to start for today, I want to talk about the word precision. Now precision comes from the term precise and trying to measure something as close to accurately as possible. So if we are trying to choose as to which type of measurement is more precise, generally the further into decimals, well, actually, hold up. Two different variations. If you are measuring using two different types of measurements, say feet versus miles, measuring using feet is going to be a more precise way of measuring using miles because feet are smaller measures of increments. Now, the other thing is if you are measuring things off of the same type of unit, so feet to feet, the one that has more decimal places or gets closer to zero is going to be your more precise measurement. So if we're looking at these examples, we have 7 centimeters versus 7.3 centimeters. 7.3 is going to be a more accurate and precise measurement because we're working in terms of tenths of centimeters versus just whole centimeters. 7 centimeters doesn't tell us much. It might have been rounded to 7. It was about 7, well, whereas 7.3 is just more precise. Like, you know, you had to use a ruler for that. Or some sort of meter stick, I guess, since we're using centimeters. For 5 yards versus 16 feet, feet are smaller than yards, so 16 feet is going to be the more precise measurement. 1 pint is the same as 16 ounces. However, since ounces are a smaller unit of measurement, that's going to be our more precise measurement. So that's the first part of this, is just which is more precise. It's not too difficult. The second thing we're going to work with is something called significant digits, or as you will use in the future in science, they refer to it as significant figures. It's the exact same thing. What we have to do with significant digits or figures is figure out how many of the digits that are there are actually important versus not important ones. Oops, I just dropped my stylus. So for example, in this very first one, if all of your digits are not 0, all of your digits are significant. So our significant digits are the 2, 8, 1, 3, 9. So your total number of significant digits or of significant figures is 5. The 2, the 8, the 1, the 3, and the 9. All 5 are significant. Now, zeros are where it starts to get tricky. Because all of, like, if, for this next one, all of our zeros that we're starting with, those are all just placeholders. They don't actually do anything in terms of telling us what are significant. But, whoops, let's get that 0 back. But the 0 after where our significant digit starts do become important because it is also after the decimal place. So our second rule comes from when we have a 0 to the right of the last non-zero digit. So our 7 is our last non-zero digit, and we have a 0 to the right of it. And it's not only to the right of that 7, but it's also to the right of the decimal point. What happens then is all of those first zeros are all placeholders. So none of those are actually significant. But then our 7 comes in and is actually measurable and therefore is significant. And that 0 after the 7 is also significant. Because if you're looking at it like on a ruler, we're not rounding to 7, it's not about 7, but we're saying, no, this is exactly on 7, and it's 0 micro anythings past that. It's just exactly there. So that's going to leave us with 2 significant digits there. Now, when we start with zeros, they are insignificant. But like in this next one, when we have zeros that are sandwiched between our significant digits, those become significant because they're sandwiched. So in this case, all 4 of those digits, the 5, the 2 zeros, and the 7, are all significant. So we'd have a total of 4 significant figures here. Finally, if we have a decimal that ends, so in this case, 800, period, that period is telling us, just like the 0 did in that second example, the final zero, I mean, that we are stopping precisely there. It's not about 800, it's exactly 800. That's going to tell us that all of those are also significant. So we would have 3 significant digits. If, in a hypothetical situation, it was just 800 with no decimal point and no significant digit at the end, that would actually only have 1 significant digit, because those zeros, just like in the second question, but the left ones, in this case they're on the right, they're just placeholders. It's just, we need the zeros to tell us that the 8 is in the hundreds spot, but the zeros aren't actually giving us any more precision to our measurement. So there's a big difference between the 800 having the decimal point and the 800 not having the decimal point. So I hope that makes sense. And if you need some more clarification, be sure to ask. So if we're going to look at a few examples here, 290.01, both of our zeros are sandwiched in the middle, so all of our digits are significant, meaning that we will have 5 significant figures here. The starting zero is a placeholder, but these 2 finishing zeros come to the right of the last significant digit and to the right of the decimal place, so they do count. So in this case, that we have 4 significant digits. And our 500 miles does not have the decimal point there, so that means those zeros are not significant, meaning that only the 5 is significant, so we only have 1 significant figure here. Now, the last thing we have to learn about is when we're doing either addition, subtraction, or multiplication, division using significant figures. When we have addition and subtraction, our rule is we have to round to the least significant, to the position of the last significant digit of the least precise measurement. So what does that mean? Round to last sig fig. I'm going to just say significant figure, sig fig. Round to last sig fig of least precise measurement. So looking at our 2 options here, 3.24 versus 7.3. 7.3 is going to be our least precise one, because it only went to the tenths and not to the hundredths place. So we can still add this like normal, and we'll come up with a 10.54, but we now need to round to the tenths place. Because it's a 4 in the hundredths, that would round down, so we're left with just a 10.5. In contrast, when doing multiplication division, you would just round to the least number of significant digits. So for our first number here with 40, that has 1 significant digit. Our second number has 2. So when we multiply or divide, we round to the least significant digit. So in this case, we'd have to round so that we only have 1 significant digit at the end. So 40 times 31, I need my calculator for this. 40 times 31 will give us 1,240, which will round to make sure we only have 1 significant digit. So that's going to round, so we actually round to the thousandths place. So our answer comes out to just be 1,000. So we're going to round to lowest sig fig amount or number. So let's look at a couple more examples here. Here we're adding, so we need to round to the least accurate measurement. So 45 plus 19 is going to be 50, 64.55, but our least accurate is just our tenths place, so we have to round to the tenths place. So that will actually round to 64.6. This one, when we multiply, our first number has 2 significant digits, our second has 3, So our answer has to round to 2 significant digits because we're multiplying. So 6.4 times 2.15, oops, comes out with an answer of 13.76. But we need to go to 2 significant figures, so that's going to round then to just 14. And that's it. That will be everything that's on this. So if you have any questions, make sure you ask, but otherwise, good luck.